here we have problem PA4-2. This is in Accounting 202, and the problem is an allocation problem. We're in Chapter 4, which is on activity-based costing and cost management. PA4-2 is on assigning costs using traditional system and assigning costs using activity proportions. So we're going to show how costs are assigned or allocated under the older traditional method, and then we'll also show how it's done using ABC concepts or activity proportions. So we have Carlisle Corp, which manufactures ceiling fans, currently has two product lines, the indoor and the outdoor fan. Carlisle has total overhead of $139,400. So let's try and set this up in some way that might work. So we have the indoor, the outdoor, and it probably is a good idea to have a total column. We can make these middle columns smaller, just separate them by a column, and we have total overhead. Cost of $139,400. And so as you might be able to tell from at this point in time, we probably need to allocate this total overhead costs somehow between these two main products, indoor fans and outdoor fans. Carlisle has identified the following information about its overhead activity cost pools and the two product lines. So what I'm going to do here is I think it's probably a good idea to recreate this information given in the problem on our spreadsheet. So why don't we put it over here? Let's see. Okay, then we have the various activity cost pools, the types of activities involved in making these products, materials handling, and quality control, and machine maintenance. Then for each of those activity cost pools, now this information is used under when we allocate costs based on ABC or activity-based costing. We use what is called a cost driver, and that would be the number of times, essentially the number of times that each of these activity cost pool categories are used, or the number of times the activity is performed for each of these cost pool categories. So the cost driver for materials handling would be the number of moves, the number of times that materials are moved. The cost driver for the quality control activity would be the number of inspections, and the cost driver for the machine maintenance activity would be the number of machine hours used in production. Of course, all of these numbers would relate to the production of the products. Then in terms of costs assigned to pools, we have $20,000 for materials handling, $82,500 for quality control, and $36,900 for machine maintenance. And then finally, under quantity or amount consumed by each of the two product lines, so for materials handling, how many moves, and that pertains to materials, how many moves were made for the indoor line, and that was 575. And likewise, how many moves were made for the outdoor line, 425. Now again, this information is all given. With respect to quality control activity, and the cost driver again is the number of inspections, then the question is, what is the number of inspections for the indoor line? And that was 6,000. And what were the number of inspections for the outdoor line? And that was 4,000. And then finally, for the machine maintenance activity, where the cost driver is number of machine hours, the question is, how many machine hours were consumed by the indoor line, 21,000, and how many machine hours were consumed by the outdoor line, and that was 20,000 hours. Okay, so let's put some formatting here so that we can tell what these numbers represent. So we'll use currency formatting for the cost column, and for the quantity amount numbers we can use something a little simpler. We can use numbers, and we can probably go with 0 decimal places. and with the numbers formatting, those numbers don't show commas, as opposed to the numbers that represent dollar or cost amounts. Dollar cost amounts, they would include the decimal point. We're using two point or two place for decimals, and shows the commas to delineate thousands. Okay, and we should probably use the same thing here for the overhead costs. Okay, now under required, it says, number one, it says, suppose Carlisle used a traditional costing system with machine hours as the cost driver. So we want to assume that, first of all, to allocate this overhead cost of 139.4 between indoor and outdoor under a more traditional cost allocation method or system, the company might use just a single cost driver. And what they're saying is, let's assume that that cost driver is machine hours, which is one of the more commonly used cost drivers for cost allocation, where there are machines involved in the manufacture of products. If there's a lot of labor, if the manufacturing of products is labor intensive, then instead of machine hours, we might be using labor hours, or as an option, we could be using labor dollars. But in this case, again, it seems to be more machine intensive. The production process seems to be more machine intensive, and so under the first requirement for the problem, using traditional cost allocation, we're going to use machine hours. And so the machine hours, we can show this over here. The total was 21,000. I'm sorry, 21,000 for indoor, and 20,000 for outdoor. And so we would want to put a total on that, and that'd be 41,000. And so under traditional cost allocation methods, we would take what we refer to as a weighted average. So we could say weighted average for indoor, and how that would work is we would take the indoor machine hours and divide it by the total hours, and that would give us a percentage, basically 51.2195%. And we can copy that formula. We can copy that formula to calculate the same percentage for outdoor, and that would be 48.7805%. And of course, we'd want to make sure that the total of these two percentages are equal to, and what should they be equal to? Of course, I know you know, 1. And so we can check that by simply adding them up and making sure that they're equal to 1, and they are. So what that tells us is that using traditional traditional cost allocation to allocate this overhead cost between the two products that the company makes based on machine hours for each of the two products. I should just call this weighted average because I've got both of them on the same line. The indoor product would be allocated 51.2195% of the overhead costs, and the outdoor product would be allocated 48.7805% of the overhead cost. And so let's see what would be a good way to put it in there. Let's take the total cost to be allocated and multiply by the percentage for each of the two, and we would want that number to be constant, and so we could copy that formula over to outdoor, and let's see what we come up with. So based on the formula, which is simple, it's taking the total overhead costs and multiplying by the percentage, the weighted average percentage for each of the two products. Total overhead cost times the percentage in F10, which is 48.780478%. I just use a floating decimal here, and that basically eliminates any rounding differences. And of course, this is a whole number in here, so what we'd want to do is double check that our calculations are correct by, why don't we use the sum formula, by summing these two amounts and making sure that we're correct. And so using traditional cost allocation with machine hours as a cost driver, the allocation of overhead between the two products would be 71.4 for indoor and 68,000 for outdoor. Now, an alternative way of coming up with those same numbers, it's a little different approach, but we should end up at the same place, would be to take the total overhead cost to be allocated and divide it by the total of the cost driver number. So in this case would be the total of the machine hours. So let's show that down here. We have overhead costs of $139.4, and then we have machine hours of 41,000. And so if we were to divide these two amounts, the cost by the hours, that would give us X dollars per machine hour. So why don't we show that as overhead dollars per machine hours. And so we would take the dollars and divide it by the hours, and that would give us $3.40 per machine hour. Let's format that as currency amount, $3.40. Maybe we should put a dollar sign on that one so that we don't get confused. So that's, again, that would be overhead dollars per machine hour. So that would be overhead per 1 machine hour. And then for each of the two products, indoor and outdoor, we could use a formula that said total machine hours for indoor times that $3.40 overhead per 1 machine hour, and that would give us the same 71.4 that we calculated up above, doing it a little bit differently. And we could use the same formula. We want to make this a constant here. We could use the same formula for the outdoor product, 68,000. And again, we would just want to show that the total of the two is our total. So it doesn't matter. You can do these types of calculations, you know, in any way that is mathematically accurate or mathematically sound, and in a way that hopefully will make sense for you. And the main thing is that you come up with the correct answer. And again, this is just for requirement number 1, which again was to use a traditional costing system with machine hours as a cost driver. Now in requirement 2, we're getting into ABC concepts, or activity-based costing concepts. So requirement 2 asks to calculate the activity proportions for each cost pool in Carlisle's ABC system. So the cost pools are materials handling, quality control, and machine maintenance. And number 2 is asking for activity proportions. So what that refers to would be the percentage that each of the two products, the percentage of for materials handling, the percentage of the number of moves in total that relate to or pertain to the indoor line, and the percentage of the number of moves that relate to or pertain to the outdoor line. Same thing for the next activity, cost pool, quality control, cost driver being number of inspections. So we want to show the percentage of the total number of inspections that relate to the indoor line, and the percentage of the total number of inspections that relate to the outdoor line. And finally, for machine maintenance, cost driver is machine hours. So we need to show the percentage of the total machine hours that relate to indoor line, and the percentage of the total machine hours that relate to the outdoor line. Now, you got to bear with me. I'm trying to go slow and be very deliberate in trying to show this information, because essentially that's what it takes. You know, you got to be deliberate and think this thing through one step at a time. to be able to come up with the information that is being asked for. So when the problem asks for proportions, essentially we're looking for a percentage. Now that might be a little tricky. That comes down to terminology, and I guess you might say you could probably glean that information from the text if you read it carefully enough. But I guess you might say that's probably one of those, a good example of why the instructor is there, is to simply provide that kind of explanation. Again, saying that when they're asking for proportions, they really want something more like a percentage. So let's see if we can get these done. I'm gonna open up some space here, just move these down a row so that we can show some calculations between each one. And so for materials handling, and maybe let's see. I had to adjust the size of the screen here. I'm just getting used to this tool. I used it in version 1, and I just downloaded it a couple nights ago in version 2. It's a little bit different from the previous version, so I need to get used to it. But what I'm going to do here is show total, which basically relates to the total of the quantity or amount for each of the 2 product lines. And I can use simple formulas here. So we got 1,000 material handling moves, and we have a 10,000 quality control inspections, and 41,000 machine maintenance hours, machine hours. Okay, and then for the proportions, we're going to do calculations that are similar to these that we did initially for requirement number 1. And basically we're going to take the amount of each divided by the total. And we need to format that so it'll show us why don't we format it as percentage, 2 places, 57.5%, and we want our denominator to be a constant, so 42.5%, and then again we want to make sure that the total of the 2 is 100. Then for quality control inspections, same formula, the total for indoor divided by the total for the 2. And again, we need to format that so it gives us the percentage using 2 places. And we want our denominator to be a constant. And then we can simply copy that formula over to the next column and make sure that we got 1 as a total, or 100%. And then finally, same formula, total for indoor divided by total for the two, and looks like we need to reformat that into a percentage. We got a decimal here, 51.2195122, but when we format as a percentage using two places, it'll reduce to 51.22%. And again, we want to make the denominator constant. So what I'm doing up here to be able to easily copy these formulas showing the denominator as a constant, I want this to be a constant in both formulas. So I simply put the cursor in between the alpha indicator for the column and the numeric indicator for the row, and then use the F4 key and press enter, and that basically makes that cell value or cell content in this formula a constant. And so when we copy this over to the next cell in the next column, as you can see, the denominator is a constant. It's still P14. And again, we want to make sure that the total is 100%. So the proportions for, what is it asking for again? The proportions assigned, the proportions for each cost pool activity. So cost pool activity being, cost pool being materials handling, the activity being number of moves. The percentage for indoor is 57.5%. Percentage for outdoor, 42.5%. The activity being quality control. The cost driver being number of inspections. For indoor, 60%. For outdoor, 40%. And finally, for activity, machine maintenance, with the cost driver being number of machine hours, our percentages or proportions are 51.22 and 48.78 for each of the two products. Okay, let's see. And we're only through number 2 of 5. Let's take a short break. Okay, now taking it to the next step for numbers 3 and 4. And again, remember that this is kind of a standalone part of the problem. This is cost allocation using a more of a traditional system. Now for ABC, we are using the information that is being developed over here on the right side. So we've calculated the proportions or the percentages for each of the activities involved in producing these two products using the numbers or amounts of the various cost drivers used for each of the activities. We've come up with percentages to use to the total cost, the percentages to apply to the total cost for each of the activities in total. So the cost assigned to materials handling in total is $20,000, and now we use these percentages to allocate this cost to each of the two products. So 57.5% of this amount will go to indoor, 42.5% of this amount will go to outdoor. So let's just show that below here. Number 3. What would be an easy way to do this? Let's start out by copying this information down. We don't need all of it, but we can remove what we don't need. let's see. Okay. So for materials handling, what would be an easy way to do this? I'm just going to replace these two amounts. Oops. Bad move on my part. Bad move on my part. Let's see. We want these to be constant. So we want to copy and paste values. So we've changed the formula. We've changed the formula to a value. Let's see if we can do that here. Okay, we've changed the formula to a value, and okay, so we've changed those formula. These are formulas, and so when I deleted the information that was used to calculate these amounts via the formula, the amounts disappeared, but I've changed the formulas to values, so we should be able to remove these amounts and keep those percentages. Okay, and so we want to calculate the amount of dollars. Maybe I should add dollars here to this column of numbers. Okay, we want to show the number, the amount of the total cost for each of these three activity cost pools for indoor and outdoor. And I guess I should bring this information down so that we can see it indoor and outdoor. Okay, so I'm going to simply take the total cost to be allocated for that cost activity pool and multiply it by the percentage that pertain or relates to that product, and that's 11.5. And let's see, the constant in that formula is the $20,000 amount, so I want to make that a constant so I can copy it easily, and I want to copy it over to outdoor line, and we want to make sure that this total is verifies that our two calculations are correct. And what should this total be? You're right, this total is the total cost allocated for this activity cost pool, which is the 20,000 of materials handling cost. And so we can verify that simply by adding up these two amounts, and it is indeed $20,000. And we probably want to format those cells as currency. Okay, so we're going to do the same thing here. We want to take the total cost to be allocated for that activity cost pool, which is the quality control, and multiply it by the percentage for indoor. And again, we want to make the dollar amount a constant so we can copy that formula over and then sum it to check our total, and we're okay. And let's put formatting on that to make it look like what it is, which is dollars and cents. Put a dollar sign on it. And for the last cost activity pool, machine maintenance, using a number of machine hours, again we take the total cost to be allocated and we multiply by the percentage of that total based on the number of machine hours that we calculated in number 2, which is a 51.22%. And again, we want to make our total cost a constant, and so we can copy that over and check the total. And we're okay, and we want to format that as dollars and cents. Okay, now what I should do, since this is number 3 and 4, number 3, number 4, this was number 2, and this was number 1, which we did 2 different ways. I'll just say number 1B here and number 1A here, 2 different ways. Okay. And then what I'm going to do here is eliminate the color on the percentages, since numbers 3 and 4 we're showing the cost allocation. And you know what I didn't do here was I didn't use 2 decimal places. I should probably make that consistent, showing 2 decimal places. Okay. And then actually number 3 and 4 are asking for the total overhead for each of the 2 products, indoor and outdoor. So the total for indoor would be the total for material handling plus the total for quality control plus the total for machine maintenance. And so why don't we show that down here, totals, and then we can use a simple formula, plus materials handling plus quality control plus machine maintenance equals. And that can simply be copied over. Oops, that didn't work. We want to copy that over to the next column, and we want to make sure that the total is our control total, which needs to be the total of these 3 activity cost pool, I'm sorry, the total of the costs assigned to the 3 activity cost pools, which is 139.4, which, by the way, remember, is our constant for overhead cost. So you see the difference here between traditional costing and activity-based costing. In activity-based cost, traditional costing, we're using a single amount of overhead, and we're allocating it based on one factor or one cost driver, in this case machine hours. Whereas in ABC or activity-based costing, we're refining it. So we're saying that this overhead cost is actually made up of 3 different main activities: material handling, quality control, and machine maintenance. And so we're going to use a different cost driver for each of those 3 types of costs. And we even have the breakdown of this 139.4 with ABC. We need to be able to break down that cost into the overhead cost that pertains to or relates to each of the activity cost pools. So again, $20,000 of material handling, $82,500 of quality control, and $36,900 of machine maintenance. And then the final step is to say, okay, now we need to allocate each of these 3 totals to the 2 products, and we have calculated the proportions or the percentages that allow us to do that allocation. So again, we got the total here, which is 139.4, and this should be our check total, which is 139.4. So 11.5 plus 49.5 plus 18.9 allocated to indoor line, and 8,500 plus 33,000 plus 18,000 allocated to outdoor line. 79.9, 59.5, which is different, as you can tell. Under the traditional allocation, we had 71.4 allocated to indoor, and under ABC we have 79.9, and under traditional we had 68,000 allocated to outdoor, whereas under ABC we have 59.5. So it's a little different. ABC is a bit more refined, I guess would be a good way to describe it, over the traditional cost allocation methods. So let's take a short break here, and we'll come back for the last part of the problem. Well, actually, in the textbook, the problem has a part 5, which is basically asking to compare traditional with the ABC and you know, come up with reasons for reasons why one or the other would be a better method to use. And actually I think I just kind of explained it, why ABC is generally considered a better method to use. It's more refined. You have a better breakdown, a more detailed breakdown of the types of activities and therefore the types of costs that are being employed in making products. And so the allocation is a more accurate reflection of the numbers of moves in the case of material handling, or inspections in the case of quality control, or machine hours in the case of machine maintenance, being utilized for each product that is being made. Is there an advantage using traditional? Of course, in traditional cost allocation, it's quicker and simpler, and you get a number that is in the ballpark, although different. And I think that's it. I hope this works. It's almost an hour that we spent on this video, and now what I need to do is try to figure out how I can package this thing and first of all send it to you, the student who has requested some guidance for this problem, and then I'll also post it on the Laulima website in modules, in the modules tool for chapter 4. Okay, I hope that helped. I hope it helps, and let me know if you have questions that pertain to it. Thanks a lot.